Hey guys, and welcome to your 10.3 notes. 10.3 is all about chords. So remember, chords in a circle are anything that cut from one side of the circle to the other. It doesn't matter where they are, how short they are. Remember that the diameter is a chord, so if it goes through the center of the circle, that could also be a chord if it's the diameter. So chords are what we're going to be focusing on in 10.3. So congruent corresponding chords theorem says in the same circle or congruent circles, so remember that means they have the same radii, two minor arcs are congruent if and only if their corresponding chords are congruent. So remember, minor arcs are going to be less than 180 degrees, and those chords that we're looking at are congruent. So over here in the picture, I see that those arcs, remember the arcs are on the outside, are congruent, and therefore I also know these chords are congruent. Okay, so everything is marked there, so minor arcs are congruent if and only if their corresponding chords are congruent. Okay, second one that we have is the perpendicular chord bisector theorem. It says if a diameter of a circle is perpendicular to a chord, so remember perpendicular, I'm looking for that right angle, then the diameter bisects the chord and its arc. So I'm going to have something that is cut in half, and it says that I'm cutting the chord in half and its arc in half. So that means FH and DH are going to be congruent, and I also know that those chords create congruent arcs. So GD is going to be congruent to GF. Those chords are congruent. Okay, so I'm going to mark those in the picture. These are congruent, and those are congruent. Okay, and the last theorem we have here is perpendicular chord bisector converse. So remember, converse just goes in the opposite direction. So if we go the opposite direction of the one we just had, it says if one chord of a circle is perpendicular to another chord, then it is the diameter. So because I know that this perpendicular bisector is happening, so these are congruent and I have my right angle, then SQ or QS is the diameter of the circle. Okay, so in the diagram, circle P is congruent to circle Q. And we also know that FG is congruent to JK. Those are all marked. And I have the measure of arc JK is 80. Okay, right here. Find the measure of arc FG. Okay, so because I know these circles are congruent and those chords are congruent, GF and JK, then I also know that those arcs are congruent. So this should equal 80 degrees, and that comes from theorem 10.6. So you guys can reference that. Okay, and exercises 1 and 2 use the diagram of circle D. So here's my circle. Number 1 says if the measure of arc AB is 110, find the measure of arc BC. So if the measure of arc AB is 110, and notice these chords are both 9, then the measure of arc BC should also be 110. Okay, so the chords are the same, so the arcs are the same. That's also theorem 10.6. Okay, and the last one says if the measure of arc AC is 150, find the measure of arc AB. Okay, so for this one, I know that these two arcs are the same, AB and BC. Okay, they should be the same. And I know that a whole circle is equal to 360 degrees. So I'm going to go ahead and subtract away the part that I know for AC. And I get that that's 210. And then each of those arcs, AB and BC, should be the same. So we're going to take 210 and we're going to divide that by 2. So we get 105 for each arc. So AB, arc AB is 105 degrees. Okay, here's an example using our perpendicular chord bisector theorem. Okay, so it says find HK. So remember, if the chord is the diameter and that bisects another chord in the circle at a right angle, then I know that this chord is being bisected here. So if NK is 7, then HN is 7. So HK is 14. It's just twice as long. Okay, and the second part of this says find the measure of arc HK. So we're going to find the measure of the outside right there. Okay, so what we're going to do, since we know that those arcs should be congruent, okay, we're going to set them equal to each other. So 11x equals 70 plus x. I'm going to go ahead and subtract x over. So I get 10x equals 70 divided by 10, and I get x equals 7. Okay, and I'm almost done. So what I'm going to do next is I'm going to take that 7 and I'm going to plug it in. Okay, those, remember, should be the same. So this gets me 77, and this gets me 77. So the whole arc from H to K is 77 plus 77. So the measure of arc HK is 154 degrees. Okay, the last thing we're going to talk about in section 10.3 is theorem 10.9 here, which is our equidistant chords theorem. This says in the same circle or congruent circles, two chords are congruent if and only if they're equidistant from the center. So remember that equidistant just means they are the same distance from the center. Okay, so chord CD is the same distance away from E as chord AB. Okay, that's what it's saying. They're the same distance away, and that distance is the perpendicular distance. Okay, so we want to make sure we are finding the perpendicular distance to those chords or to the center of the circle. So in the diagram, QR equals ST. Okay, so I'm looking at those, QR and ST, and they both equal 16. So this is 16, this is 16. Okay. CU equals 2x, and CV equals 5x minus 9. Find the radius of circle C. Okay, so what I'm going to do first is I'm going to figure out what x is. So I know that these two pieces are congruent, so 2x equals 5x minus 9. I'm going to subtract my 5x over, and I get negative 3x equals negative 9, and I'm going to divide that by a negative 3. So I know that x equals 3. Okay, the hard part is that's not what the question was asking for. The question wants me to figure out what the radius of C is. Okay, so I need to figure out what the radius of C is. So what I'm going to do is I'm going to create my own triangle. Okay, we'll make it red. Okay, so here's my triangle that I'm going to create. I'm just going to connect that right back to the center. This should be a right angle. So I now have a right triangle, which is going to help me out. So what I'm going to do is just draw that right triangle over here to the side. Okay. What we do know is that this chord, this whole chord is 16, and they're being bisected. So each side of this should be the same. So I know that one side of that chord is going to be 8. Here's my right angle. Okay. And then I also knew that this was 2x. Okay, we just found out what 2x is. So 2 times 3. So I know this side is 6. And I'm trying to figure out what my radius is. So you could use x there, or you could use r for radius. And then we're going to solve for that r. So since it's a right triangle and I know 2 out of the 3 sides, let's use Pythagorean theorem, which remember is a squared plus b squared equals c squared. And I know my 2 straight sides are 6 squared and 8 squared, and my hypotenuse, we're saying that's r to find our radius. So we are going to simplify this. I have 36 plus 64 equals r squared. If I add those together, I get 100. And when I take the square root of both sides, I get that r is 10. So my radius is actually 10. Okay, your homework is on Clever, guys. Make sure you're asking questions if you have any. That is all for 10.3.